So question 17.32, this is a complicated question, especially the second part of it. What I would like you guys to know is definitely the first half of it, be able to figure that out. So you have to prepare a pH, buffered solution of pH 5.01. So the key to that is basically, if you remember when we were talking about buffers and figuring out the best buffer to use, you want a buffer works best when it's at a pH near or equal to its pKa. So based on that, this acetic acid sodium acetate combination would be the best buffer to use because it has a pKa of 4.74, which is the closest to our pH of interest, pH of 5. The formic acid sodium formate is too low, and the sodium cyanide is way too high, the pKa of 9.3. So the first thing we need to do is find out what that ratio is. So if we use the Henderson-Hasselbalch equation, pH equals pKa plus the log of the concentration of base divided by the concentration of acid. They give us the pH, we know the pKa, so simply subtract the pKa from pH and we get 0.27 equals the log of the base divided by the concentration of acid. Now we can simply find what that ratio is by doing the reverse of the log, so 10 to the power of 0.27 for a ratio of approximately 1.86 base to acid. Now we need to find out what that ratio is, what those actual concentrations are, so that we can know how many milliliters of base to add and how many milliliters of acid to add to make a 1 liter solution of this buffer. So for that, I basically said, well, the concentration of base that we add is going to be starting with 0.1 molar. They're all 0.1 molar solutions. We're going to multiply that by a factor of x to get some fraction of that. And for the acid, we have, to make up the remainder of that 0.1 molar solution, we're going to have basically 0.1 minus whatever we get from the base. So minus that 0.1 times x, this being basically what we calculate, what we get from the base, what concentration. The remaining concentration will have to come from the acid. So if we multiply this across, we get 0.1x equals 1.86 times 0.1 minus 0.1x. We factor 1.86 through there, and we get 0.1 equals 0.186 minus 0.186. And then all we need to do is basically add that 0.186 across to the other side. And that should get us in a pretty good situation to solve the rest of this equation. So now we get 0.286 simply by adding the 0.186 across. Now all we need to do is divide by 0.286 to figure out what that x is alone by itself. So divide both sides by 0.286, and we should see that x equals about 650, or 0.65, which is liters. We need to make a 1 liter solution, so 1 minus the 0.65, and we'll see we'll need 0.35 of the acetic acid. And if we wanted to convert that to milliliters, basically that 0.65 liters becomes 650 milliliters. And the 0.35 liters becomes 350 milliliters. So simply by solving for x, that allowed us to find what the concentration or what the volume of sodium acetate was used. And basically, because we needed to make a 1 liter solution, the remainder of that volume came from the acetic acid. So 1 minus 0.65 gave us the required volume of acetic acid to use. So like I said, the important thing is part A from this, basically knowing what pair you'd need to use based on the pH that they're looking for you to make that solution at.